So hello everyone and welcome back to my channel, and here basically I'm back with the part 4 of nested ranges problem, and here I'm going to be discussing with all of you the code. So before going to the PBDS based implementation, let's try to see the basic syntax, how you can try to define it. So these are the extra namespaces and libraries that you are required to import alongside defining the structure utilizing which we are going to have the login based queries enabled. Okay. So basically how we can try to define our policy-based data structure. So see, that's going to be the syntax, and whatever is the overall structure you have defined, right? That's going to be, I am referring with the help of ordered multiset, this specific naming. Correct. This ordered multiset, whatever I have defined here, right? This would be acting as an alias of this entire data structure, whatever I have defined. And I'm going to be saying that let's try to define this data structure accepting any kind of generalized data type. So I'm going to be referring that with the help of a template. So that while defining the container for my usage, right, this template T can be replaced with any kind of data structure, let that be integer, float, string, whatsoever you wish, depending upon what specifically our needs are, right? So what do this null type suggest here? This null type is for the sake of mapping of data. Since right now we are dealing with a set of endpoints, right? Whatever we have discussed onto the previous video, that there can be multiple 4s, there can be multiple 5s. So we can try to define our structure in terms of a multiset. And I can just say that, okay, no specific map kind of representation we require, that 4 is being mapped with a specific other data 3 or something like that. Just the individual data is sufficient. So that's why this null type we have mentioned here, that overall data structure is not going to behave in terms of a map. Correct. Less equality, that's the functionality overall my respective multiset is going to hold on for. And after that, the internal implementation would be based on red black trees for the sake of balancing, so that login based insert, delete, and query operation can be enabled. And this is the extra operation, what's going to be enabling the overall insertion, deletion, and updation of internal nodes, whatever my overall tree is going to have. So that's how basically we can try to define this data structure, right? These are the functionalities. Overall, the ordered multiset, that's how the type we are going to define. And how basically its object you can try to create. If I try to call on for that, you can just define the variable, and appropriate to that a container would be created, and you can try to refer the container with the help of variable s. So these are the insert operation, s.insert, that's going to be holding for us how I can try to insert data within my container. And after that, there are specific queries that you can try to utilize, and you can just straight away say that find by order what this functionality is going to do for us. What is the zeroth smallest data? What is the first smallest data? What is the second smallest data? So these are the data points, whatever we can try to fetch with the help of login based query utilizing this function find by order, right? And overall our entire container is going to it's going to support that. And after that, if you call on for the order by key, then this functionality is going to be the crucial one for us right now. Why? Because if you give the order by the order of key based of functionality, right, and mention here any number, then this specific thing returns how many numbers are actually smaller than 6. Strictly smaller than 6, it's what the function is going to return. Correct enough? So these are the functionalities we are going to utilize. Specifically the insert function and order of key, this specific functionality, in order to implement our nested ranges count problem. Okay. So let's move on to the coding part, and let's see how that's going to be a bit different as compared to that of nested ranges check counterpart. Majority of the portion is going to be same. It's that a bit of query based stuff we are going to introduce there. So here I am onto the code part, and I have already coded up this problem. So I'm just explaining what specifically I have done extra onto this corresponding problem, right? So these are the extra namespaces and libraries, whatever I have imported, defined the ordered multiset there, whatever I'm going to require. The sorting and everything would be remaining same only. It's that multisets are the extra stuff we are going to define here for different purpose, right? So let's first go to the part of your respective contains problem, right? A specific range contains how many other ranges. That's what specifically we are required to calculate in terms of count. So suppose that right now you are onto the ith range, right? You are onto the ith range, and it has specifically a start and end associated. So this range is going to contain how many other ranges? So I think we were going for the contains counterpart from bottom to up direction, right? Correct enough. So all these respective all these respective range endpoints from I plus 1 till n minus 1. Whatever are the specific endpoints of these ranges, I will put them within my container, the PPDS, whatever I have defined. Correct enough? Correct enough. Now, whatever is the current endpoint, right? How many of the respective endpoints are going to be contained within the current range, whatever I'm dealing with? So, whatsoever container based en prime that are specifically uh, lesser than or equal to that of end of my current range. I think that's gonna be the scenario we are required to look on for. Count them all. How many such end primes exist? Count them all. Correct enough. So I can just try to utilize the order of key this specific functionality, and equality is required to be supported. So I'm required to mention here the argument n plus 1. Since my current range has an ending point en, right? Whatsoever ranges are ending with values lesser than equal to end, all of them I require from the respective container whatsoever I have already created. So I think this specific stuff can be boiled down to how many ranges are there whose endpoints are strictly lesser than n plus 1. Correct enough? Whatever may be their account, I can just try to query them with the help of order of key, this specific functionality. Correct enough? Correct enough. And whatever is the original index associated with my current range, right? I can just grab on that and assign the overall result corresponding to that index within the contains array. And now here, as per this functionality, the respective count would be stored. And after that, the ith range answer has been calculated going forward for I minus 1, whatever is the previous range that is available, right? For that, the ith range endpoint is required to be inserted within the respective container. So I'm going to be saying that within the respective empty container, whatever you have defined, a PBDS, insert your current endpoint, whatever you are dealing with. So that's how specifically I can try to proceed ahead for the sake of calculation of contains part, right? And now, once you go ahead for the sake of is contained part, how the stuffs are going to look like. So see for here, I think for the is contained part, right? Whenever you add the ith range and it has a start and end associated, then from 0 till I minus 1, how many ranges are there whose endpoints, end prime, let's say, are greater than or equal to the endpoint of my current start to end range, whatsoever it is. Correct enough? Correct enough. Now, how basically we can try to handle that? What does the order of key brings us? It says me that whatever end you are dealing with, right? How many container values are there, such that their end primes are strictly lesser than end. Correct? Such that they are strictly lesser than n. Now, this start to end can be contained within how many other ranges? From 0 till I minus 1. I can just straight away say that whomsoever are having start values lesser than or equal to that of the current start of my range, and end values again greater than or equal to current end of the range, whatever I'm dealing with. Within all of them, the current range is going to be contained. So I'm just required to see how many of the endpoints, whatever are the previous ones before reaching the current one, are actually following this specific scenario. Whomsoever values end primes, right? They are greater than or equal to the end part, right? They are greater than or equal to the end part, whatever the current range is holding. But this order of key is going to bring me strictly lesser values. So I can just straight away say that whatsoever ranges you have traversed so far. So if I'm standing at the ith range, right? Overall, I number of ranges I have traversed overall. So among all of them, right? Among all of them, how many ranges are coming with the lesser endpoints? Let me call that as L. So I will subtract that. Remaining one, whatsoever it is, right? All of its endpoints would be either greater or equal to that of endpoint of my current range, whatsoever I'm dealing with. So that's what I'm going to assign to the index counterpart of my respective contained array, right? I have grabbed on the index from the second available tuple index, whatsoever I'm storing in terms of the overall ranges. Okay. I have stored the ranges how in terms of a vector of tuple. So onto its second index, right? The original index corresponding to the input is being stored. So I have already grabbed on that. And based on that specific index value, I'm storing the final result. Correct? And after calculating for the ith range, whatsoever I'm having, right? I am required to go to the I plus first range. So before going to that, the ith range endpoint is required to be inserted within your respective container. So I've defined a separate container for the sake of is contained counterpart, and I've called that as MT2. So within that, the current endpoint you are required to insert. And after that, you can try to facilitate the print operations. So overall code is more or less the same, whatever we have already done. For the sake of your nested ranges check problem, it's that how to count on for the respective values for the counterpart of nested ranges count, right? We are required to facilitate that within log and query time complexity. So for that, I have defined policy-based data structures. So I hope all of you like this video. If any kind of doubt specifically you are having corresponding to that of the code implementation or anything else, you want me to clarify some other stuff, right? Please feel free to comment within the YouTube link. And if you like the video, please like, share, and subscribe. And again, let's meet into the next set of problems. Thanks all. Bye.